Good morning. Excuse me. Good morning. This is pre-algebra for Friday, March 27th. I wish you were here. I miss you. This is not the way I wanted to teach this year, but I hope you're all having a good time, I guess. I don't know. I hope you're being quarantined and sheltered in place is not terrible for you. I do miss you so much. I hope you're walking with God. Did you read your Bible this morning? I hope so. I was reading my Bible this morning. Actually, I was reading Revelation. It's not a book that I spend a tremendous amount of time in, but I was reading today in chapter 3 about the different churches and how some churches God said were worldly and how some churches God said were materialistic. And some churches he said, you know, you're going through a trial, but you're doing it with the right spirit and you're loyal, and I love that about you. He even said to one church, you're dead. Oh, you're saved and you teach the right things, but you have no service. And I thought, boy, I sure don't want to be like that during this time. I want to make sure that I'm telling people about the Lord, have the opportunity to pass out door hangers, you know, gloves on, and you put them on everybody's doors. And though they can't come to the Easter program at the church, because at this point we won't be able to have one, but they can watch on church online. I hope you're doing that. FBC.Hammond. Watch Pastor live stream. He's live streaming Sunday morning, Sunday night, Wednesday night. In fact, every night, Monday, Tuesday, Thursdays, and Fridays, he's even doing a little fireside chat kind of. It's I think it's in his living room. I can't really tell. I don't know. I've never been to their house, so I don't know. But it looks like the living room and him, Mrs. Wilkerson, are just chatting with us. I hope you are doing that. Set your alarm on your phone for 7 o'clock tonight, and just watch it. It's a little encouraging. He loves telling his corny jokes, which we love about him. He gave a joke yesterday. It was, what do two porcupines say when they kiss? The answer is, ouch, ouch. So, okay, that's kind of a corny joke, but that's the one Pastor told, so I thought I would share it with you. All right, but back to the matter at hand. Pre-algebra. We are on lesson 77, and we're not going to do the whole thing today, so, whew, all right, not so much homework today. Now, you are going to notice that on today's list, there is a homework, there is a quiz, and there is a lesson. And obviously, this is the lesson. The homework is from your book. Okay, and I've typed it on there, and I've made it so that you can get the answers right away, and you'll know if your answers are correct or not. That is to help you see what you're doing right, what you're doing wrong, okay? It also helps me as I'm grading you and as I'm getting your grades ready. You are getting ready to get we're approaching here. We've already finished. This is our last one for 2 weeks. So after next week, I want to send your grades to you and let you know where you stand right now on your averages, okay? Because I know it's a little different, not talking to me, not being able to come to my desk 14 times a day and say, what's my grade, what's my grade? All right, so I want to make sure you know what your grades are. Today, we're going to talk about something we've not talked about yet, and we are going to talk about right cylinders, right circular cylinders. A right circular cylinder is nothing but a tube. That's what it is. It's just a tube. Now, we're going to find we're going to find 3 things out about this tube. First, we're going to find the volume. Second, we're going to find the surface area. And third, we're going to find the lateral area. Okay, so I'm going to explain each one as we go. We know that volume simply means how much can I fill up. If I take this tube and I fill it up with little square measurements of maybe an inch cubed, how many will fit inside this jar? Okay, how do I solve that? We're talking about finding the volume of a circular cylinder, okay? To find the volume of a circular cylinder, volume equals area of the base times the height, okay? So write that formula down. It may actually be in the back of your book. I'm gonna look real quickly. I should have beforehand. They give you a little chart. They do not. Okay, I don't know why they don't put that one on there. But to find the area find the volume of a cylinder, you're going to find the area of the base and multiply it by the height. Now think about that. That's exactly what Mrs. Turner taught you to do with a square. I would tell you find the area of the rectangle, multiply it by the height. It's the same idea, except now our base is a circle instead of a square. Okay, we're going to say, first of all, what's the formula? What's the formula to find the volume or the area of a circle? To find the area of our base, we have to say pi times radius square. Okay, once we find that, then we multiply it by the height. So let's take this for example. I used the one in your book. If this is a 2-inch radius, just like it is on the example in your book, a 2-inch radius, then I go to my formula and I can say volume equals 3.14 times radius square, where the radius is 2. Okay, so it's 2 squared times the height. And this said that the height was 20 centimeters or 20 meters. Okay, 20 meters. So now all I need to do is solve my formula. I'm going to say volume equals 3.14 times 4, because 2 squared is 4, and multiply that by 20 meters. Now I'm going to have to go out here to the side. I have 3.14, and when I multiply that, I get 12.56. 12.56. Then I'm going to multiply that by 20. 12.56 times 20 is 251, and I'll look over here in my book, 20 meters cubed, okay? Now, let's walk through that again. In order to find the volume of my cylinder, I'm going to find the area of my base, multiply it by my height. So to find the area of a base, that's a circle, I say pi times radius square, then I multiply by the height. Well, pi is 3.14. The radius of this particular one is 2, so it's 2 squared. So 3.14 times 2 squared is 3.14 times 4. Pi times 4 is 12.56. Then I multiply it by the height. So 12.56 times 20 is 251.20. And that is cubic units. In this case, it was cubic meters. Now, remind you, on your online form, do not put cubic meters. Just write the number, because I don't want the computer to mark it wrong because somebody put a space and somebody else didn't. Okay? So that is how we find the volume of a cylinder, a circular cylinder. We simply say the area of the base times the height. Now, what about that second thing Mrs. Turner said? That is the surface area. How do you find the surface area of a cylinder? Well, let's think about what surface area is. Surface area means I want to cover the top, cover the bottom, and wrap the middle. In other words, how much Christmas paper does it take to cover this cylinder? Okay? Now, in order to find that out, we're going to say I need the area of the top and the bottom. Now, you just told me, so I put it over here, we have to find the area of the top, the area of the bottom. Notice here I put area of the R. That means the area of the rectangle. You say, Mrs. Turner, it's a circle, it's not a rectangle. True. But if I took a piece of paper and I wrapped it around this, and then I cut it down the seam and I opened it up, it would be a rectangle. Okay? Now, I'm going to show you how. Now, obviously, you can't do that with this plastic jar. How would you then know how big to make it? I'm going to show you that. Okay? So first, we're going to go to the area of the top. How do I find the area of the top of a circle? I say pi times radius squared. Notice on my formula, I put 2 times pi times radius squared. Why? Because the top and the bottom are exactly the same. They're exactly the same. So when I find pi times radius squared for the top, if I multiply that by a 2, that gives me the top and the bottom. Okay, then for the area of my rectangle, or the area of the middle here, okay, what I'm going to say is pi times diameter, okay? Pi times diameter is going to tell me the width of this. If I were to cut it open and I lay it out, the width is going to be pi times diameter. Then the length of it is simply going to equal the height. So that's going to tell me everything I need to know. Okay, because remember, if we find the area of a rectangle, we say length times width. And that's in essence what we're doing here, but because it's a circle and I can't lay it out flat, I have to use the same thinking, different formula. Pi times diameter gives me the length, and the height gives me the width, okay? Now, all I have to do is go back and fill these in. So, if I'm looking at this circular here, but I'm gonna make this one, I made it on the bottom, I made it say 3, okay? If our radius is 3, let's look at this. We're gonna say surface area times 2, pi is 3.14, times our radius, which we just said the radius was gonna be 3. We're going to square that. Then we're gonna say the pi, I'm gonna leave this as pi because I'm gonna show you a little shortcut here in a second, okay? So we're gonna leave this as pi. Excuse me. The diameter. If the radius is 3, the diameter must be 6, okay? Then the height is going to be 20, okay? The height is 20. Now, let's go back and solve this. We're gonna say 2 times pi, 3 times 3 is 9, that's plus, we have pi times 6 times 20. Well, let's get rid of that 6 and that 20 and just make it pi times 120. All I did was say, because this is multiplying, I don't have to use the parentheses, okay? It's not gonna change my answer. So it's 120, and here's pi times 9 times 2. Now, we're gonna, because we have times 2, this is really gonna be what? 2 times 9 is 18 times pi plus 120 times pi, okay? So now let's add these. We have 138 times pi. So I literally am saying 138 times 1.34. If I multiply that out, it gives me 433.32. In this case, because it's surface area, it's meters squared. Now, what I did is I left all of my pi's. That was so that I could multiply by 3.14 only one time. It was going to make it a little easier. I'm going to turn this a little bit so you can see it, I hope, a little better. Because if I have to multiply by 3.14 so many times, I'm more apt to make a mistake with my decimal, okay? So by waiting to the end to multiply by 3.14, I'm not using as many decimals. I'm not going to make as many mistakes. So let's walk through it again. Surface area means to cover all the sides of my cylinder. So the top and the bottom are the same. So I'm going to put the area of the top plus the area of the bottom plus the area of this rectangle that's wrapped around the middle. Okay, so let's break it down. In order to find the area of the top, I'm going to say pi times radius squared. Since the area of the top and the area of the bottom are exactly the same, I'm going to multiply that by 2, and I'll have my area of both of them. Then, to find the area of this middle part, this rectangle, okay, to find the length, we're going to say pi times diameter. Then we're going to multiply it by height. Now, since all of this is getting multiplied together, it doesn't matter the order that I multiply them in. I can say 2 times 3 times 4 is the same thing as 4 times 3 times 2. I can put them in any order I want because they're all multiplying, okay? So now I'm going to go back and fill it in. I have a 2 times pi. My radius was 3, so I have 3 squared plus pi My diameter is 6, because diameter is twice the radius, so it is 6, and the height is 20. Now, let's go back and put everything down to where all I have is pi and a number. So I have 3 squared is 9, okay? Everything else I just brought down. So 2 times 9 is 18 pi. Up here I said 2 times 20 was 120, so it's 120 times pi. 18 plus 120 is 138 times pi. What is pi? 3.14. So 138 times 3.14 is 433.32 meters squared. Now remember, area is always in square. And since this is a surface area, my answer is meters squared. Volume is how much can it fill up. So volume is always cubic meters. But again, on the online questions, you're only putting in the number, not the units. We're going to have to really stress that while we talk. That way you'll know which one is which. Now, there's one more thing that I need to teach you about this cylinder, and that is the lateral area. That is a new term for us. We did it briefly just one time when we did a rectangle, but really didn't spend a lot of time on it. Today, I want to make sure you understand it. Lateral area, the word lateral means the same. If I make a, when I taught at my previous school, I was just a teacher. When I went from just being a teacher at that school to coming to City Baptist and I was just a teacher, that's a lateral move, okay? Now, previously, I had been a teacher in Missouri. I was a teacher. Then, when I came to Indiana, I became a principal. That was a higher position. Those are not the same, okay? So that's not lateral. Lateral means two things that are parallel, okay? In this case, when we talk about lateral in geometry, we're talking about the up and down spaces, okay? I'm not going to count the top. I'm not going to count the bottom. I'm only looking at what does it take to cover the middle. What does it take only to wrap the middle of my cylinder, okay? The lateral area is just the sides. Now, we're not going to, if I wanted to calculate lateral area, I would say LA for lateral area and write the formula. And let me ask you a question. What part of our surface area formula did I use to find the lateral area? Well, I used pi times diameter times height, because that gave me the length and the width of this rectangle that's wrapped around it. That's our lateral area. We're not going to calculate it right now. We're going to look at some other things, okay? Let's look at number 1 in your problem set today. A harsh law called a Dacron law after the Greek lawgiver Draco. 2/5 of the laws were Dracian. If 42 laws were Dracian, how many laws were there in all? What formula do you need in order to solve that problem? Think about your pattern. Think about the pattern. Hopefully you said the fraction times the of equals the is. Write that down on your paper. Now, let's fill in what you know. Well, you know 2/5 is the fraction. We don't know how many the of is, so we can put times n, okay? And it equals what? 42. Okay, the n is going to be the same as our laws, okay? So we're going to have 2/5. I think I used the word L for laws up here when I wrote it on the board, okay? We have 2/5 times L, or the laws, equals 42. So I came down and said 2/5 L. All I did was take that multiplication sign out to make it look like an equation. 2/5 L equals 42 over 1. Well, when I saw 2/5 L, I knew I needed to use the reciprocal. So my reciprocal is 5 over 2. Whatever I do to the left, I must do to the right. All of these are going to cancel, leaving me L equals. Well, go to this side. What can I cancel? I can cancel the 2, it becomes a 1, and the 42 becomes a 21. Now I multiply by 5. 21 times 5 is 105. There were 105 Drakean laws. Okay, 105 of them. Now, let's look at number 2. It says a neophyte is a beginner. Are you a beginner at something? Have you started something new during this shelter at home time? I hope so. My husband and I were talking about some things that were like, you know, we're both still working, but we still are home a lot more. He's not traveling, and today's his birthday, so I'm kind of doing some special things tonight for him. Can't take him out to dinner or go buy him anything, but I can still make tonight special by making some of his favorite foods. And my girls and I have already decided we're gonna play his favorite game. One of the girls is making a birthday cake. But we're going to try to spoil him because he's not normally with us on his birthday. And so whenever you do something new, you're a neophyte, okay? Now that doesn't mean that it's a particular thing, it's just a beginner, anybody that's a beginner, okay? So you were at one time, someday, for some of you, it was a long time ago in first grade. I think McGuider, didn't you say you came in first or second grade to City Baptist? Whereas Yoslin, this is your first year at City Baptist. But both of you were a beginner at City Baptist at some time, okay? Here we have, on the first day of classes, there were 28,000 students arrived at the university campus. If 3/7 of the neophytes, how many were not? So in other words, how many were returning students? Well, let's look at that. We have the same pattern, okay? Our fraction of times the of equals our is. Our fraction is 4/7. Our of is 28,000. We don't know how many that is. So what are we going to do? Well, this is really over a 1, so we're going to reduce. We're going to divide by 7. This is a 1. 7 goes into 28 4 times, making this 4,000. Now I'm simply going to say 4 times 4,000 is 16,000. So N equals, or the non-neophytes, are 16,000. It's 16,000 returning students. Obviously, that was a huge university. Look at number 3. Patton drove his column north and covered 60 miles in 3 hours. By how much did he need to increase the column's rate in order to complete the last 200 miles in the remaining 5 hours of daylight? Well, first of all, how fast was he going? He was going 60 miles in 3 hours. We need to increase it some amount, okay, in order to do the 200 miles in 5 hours, okay? So the first thing I'm going to do is I'm going to reduce this. I'm going to say 3 goes into 60 20 times. So now my rate is 20 miles per hour. I need to increase from 20 miles per hour some amount because I need to do 200 miles in 5 hours. Well, reduce that. 200 divided by 5 is 40 miles per hour. If you're going 20 miles an hour and you need to be going 40 miles an hour to find out how much you needed to increase, let's do it just like an equation. Subtract our 20 miles an hour from each side, giving us the only thing left, the n, that's the increase. 40 minus 20 is 20. We needed to increase by 20 miles an hour. He literally needed to double his speed, didn't he? All right, let's look at our next one. It says, the ratio of timorous to the undaunted, in other words, those that were timid, those that were frightened, to those that were not afraid of anything, was 5 to 17, okay? If there were 200 that were timorous or shy and uncertain, how many were undaunted? Well, let's make our ratio. Our ratio is going to be 5 to 17. 5 people were shy and timid. 17 were not afraid of anything. Now, what we know is if there were 200 of them that were shy, We have to make the timorous or the shy ones on the same level, so I put 200 on the other side. And I don't know how many are undaunted, so that becomes my X. I have a ratio here and a ratio here. Since these two ratios have an equal mark in the middle, meaning they are balanced, they are equal, what is that called? Hopefully you knew it was a proportion, okay? These proportions can be solved by cross multiplying. So we say 5 times X and we get 5X. Then we said 17 times 200 is 3,400. Now, I have the equation 5X equals 3,400. How do I solve it? 5X means to multiply. So instead I divide. Remember, this is the only time in your life you're allowed to be the rebel. Do the opposite of what the equation says. But remember, that's rule number 1. Rule number 2 is whatever you do on the left, you must do on the right. So we're going to divide instead of multiply, and we're going to divide by 5. Whatever I do on the left, I have to do on the right. 5X divided by 5, these 5's cancel, leaving me only the X. 3,400 divided by 5 gives me 680. So there were 680 undaunted players in this ratio that they've given us, whereas 200 of them were shy. Look at number 5. Can you graph number 5? This is the any quantities that we were talking about yesterday. X is greater than -1. If X is greater than -1, there's no equals mark, so I'm going to circle it. And since it's greater than, I'm going to go to the right. Okay? What about this one? X is less than or equal to 0. Since it says less than or equal to, do I circle the dot or fill it in? I'm going to fill it in. So go to 0, make it a dot. Now it says X is less than. So I need to go to the numbers that are less than 0, which is going to be toward my negative numbers. Hopefully you were able to do that. Our last one that I'd like to try to do together, we're running out of time, is to complete the diagram by finding A and B, okay? You have a percent here of 780. That's the 100%. So what is A? What is 40% of the 780? That's what it's asking you. Letter A says, what is 40% of 780? Well, I'm going to go over here and say 40 over 100, because that's 40% of 780 is. Now you multiply it out and you find the answer. Okay, hopefully you found your answer to be 124 is 40%. Okay, it's 40%. Now, look back at your thing. It says that 468 is blank percent. You're supposed to find the percent. All you have to do, if this is 100% and this is 40%, how much of this is left? 60%. 100 minus 40 is 60%. Okay, tonight for homework, it is online. I want you to do it online because I want you to get your feedback right away of what you're doing right and wrong. You're only going to be doing down through number 15. Only through 1 through 15. Keep your paper. Hope you wrote these down because you're going to be allowed to use the work that we did in class to help you with your online grade. Okay? All right. You'll need to take a quiz today and do your online homework. Have a good day.